Hello everyone, my name is Kacper Szurek and today I'll be talking about privilege escalation on Windows using third-party services. Few words about me. I am working in ESET as a detection engineer. I am also doing some vulnerability research, so you can check my website. I am also active on Twitter. Today there will be a lot about services. So first I will explain what the service really is. After that, I will show you three standard methods on privilege escalation. After that, we have multiple examples of real-world softwares which are vulnerable, so you will see what type of bugs the vendor have inside their software. So Windows Service is something like Linux daemon. So it's a long-running application which is running in the background and does not have any graphical interface. Usually it starts on the system boot up, and most of the services are running as a system user account. And on Windows, system user account is the most powerful account. So if you have system privileges, you can do anything you want. So that's our goal in privilege escalation, obtaining system account. And nowadays there are a lot of services installed on the Windows. And you might start thinking, why services are so popular? And there is one reason for this. In corporate environments, usually users don't have administrator privileges. So if you want to use some software which require, for example, changing IP address, you need to have some service which will be responsible for doing privileged operation in the current user context. When you are doing pen tests, there are a few standard methods of privilege escalation. First one, when you check service details using this graphical interface, you see something called path to executable. And that's the path that will be executed when the service is started. And here, this path is encoded using double quotes on both sides. But let's think what will be if there will be no those quotes, and the path will contain some space. Then operating system doesn't really know which part of the path is the real executable and which part of the path is the arguments which should be passed there. So the Windows is trying different files in this order. So the exploitation is simple. We are checking services which do not have double quotes and contain space. Then we are checking if we have some write privileges to one of those localizations. On Windows, we can define files and folders to which user has access. So let's think that standard user has write permission to the folder in which there is some service executable. So the standard user can easily replace those executable. And after, again, system reboot, those executable will be running with the system privileges. So instead of original one, our malicious payload will be executed. And the last example, we can also specify permissions for service configuration. So when the vendor installs new software, he needs to create also service. And he's also specifying which user has permission to changing those service. And if the vendor configured it wrongly, we can, as you can see on those screenshots, changing path to executable. And that's very easy. We only need one command line, and that's all. Our service will be executed as a system. But that's the standard way. And today I will be showing you another way of privilege escalation on Windows. In presentation title, I use word third party. So you may start thinking, why? And the answer is simple. It's very hard to find something interesting and exploitable in standard Windows services. Also, nowadays, we install a lot of software. And there is a great chance that one of the software is vulnerable. And that's my idea of exploitation. So as I said before, services do not have graphical interface. So we need to somehow communicate with the service. And on Windows, there are several methods of inter-process communication. Today, I will be speaking mostly about pipes and sockets because they are most important. So let's time for examples. I will start thinking, okay, nowadays we have a lot of VPN service providers. So how does software really works under the hood? So I check a few of them, and it looks like most of them works exactly the same. So we have this beautiful graphical interface. So that's the place when you choose which server you want to connect. Also, that's the place when you put your credentials. And you are clicking connect. Under the hood, this client is sent some magic packet to the service. And this service is running as a system. And this service is running in the background OpenVPN. OpenVPN, so that's the open source software. So I will start thinking, okay, why they are running some open source software in the background? And the answer is simple, because creating own VPN server is not an easy solution. So we have something which is executing some third-party binary as a system. So maybe I can encourage those services to execute my own binary as a system. And that's the idea which I tried on different VPN software. First example, very simple. Let's think that there is some software which in loop waiting for connection to the socket. And all data that are passed through that socket are converted to the string. And those string is passed directly to the API create process. And as you may think, create process API on Windows is creating new process. So here is exploit, very simple. So I am creating temporary bat file. And this bat file is responsible for creating new user and adding it to the administrator group. And after that, I am sending simple packet to the socket, which contains path to this bat file. And that's all. Few lines of code, and we run some code with the system privileges. So as you can see, very basic example of the privilege escalation. And when we look into IDA, how this binary looks like, it's very simple. This software was written in Qt. So instead of create process API, we have some Qt wrappers. Here, QProcess start. And the same idea might be used also when you are using other inter-process communication. Here, another exploit. Very, very similar. Right now, I am using pipe instead of socket. And one little quirk here, they want to have path encoded in UTF-16. But the rest is the same. And again, it looks very, very similar. So we are reading everything from the pipe, then pass it directly to the function, and those function is executing create process API. So that's the basics. So how the vendor can improve their software security? Example number 2. One of the vendor knows that executing everything that is passed to the socket is not a great idea. So he creates some kind of checksum mechanism. So when you want to send some command to the service, first you got challenge from that service. And you need to somehow calculate response for this challenge. And the response is, you know, some XOR operation or some mathematical calculation of the challenge. And only when you send proper response for a specific challenge, your command will be executed. Okay, so in theory, it looks great, because I cannot simply pass the path to the executable. I need to have some response for the challenge. But let's think about this for a while. So we have original client interface, and this client is also sending some commands to the service. So this client needs to somehow calculate those response. So inside those client, I find function which is responsible for calculating those response. And because client is standard application, me as an attacker can easily open it in some reverse engineering tools. So I can easily know how the encryption looks like. So as you can see, those protection is not protection at all. On the right side, there is some screenshot how of the vendor creates some challenge and response. And as you can see here, it's simple XOR operation with the static key. And that's all. So the final exploit looks like this. We got and one little quirk here. They use also port name for the XORing operation. And that's all. The same idea as previously, but right now we have some challenge. Okay, so how we can improve this software even more? So we know that executing everything which is passed through the socket is not a great idea. So maybe we will be executing only specific binaries. And that's the example number 3. So one of the vendor has this idea that we give service a path and the service is calculating some hash, for example, MD5, and then compare this hash with the list of known hashes. And only if the service knows this hash, it executes the file. If not, nothing really happens. And here is how those security mechanism may look like in Python. So first I will start thinking, okay, so MD5 is not so new, so maybe I can do some brute force. But I don't have too much graphic cards, so it's not a great idea. So I was thinking maybe there is another way to exploit those kind of things, because security vendor can easily replace MD5 with SHA-1 or SHA-2456, and I cannot create collision for SHA-1. So what do we know? We know that the service is executing OpenVPN as a system. And OpenVPN is a rather complex software. So I start digging into the documentation. And after a while, I found this. As you can see here, OpenVPN has this app command functionality. And that's the command which will be executed when the OpenVPN is successfully connected to the server. So let's think about this. We have service which is running as a system. And those service is executing OpenVPN as a system. And OpenVPN is running as a system, so also app command will be running as a system. So exploitation looks like this. I cannot modify OpenVPN exe because they calculating MD5 hash. But I can modify command which is passed to this binary. So the final exploitation looks like this. As you can see here, I am not passing path to the bat file directly, but I am passing this path inside the app command. So how we can improve this even more? So we know that passing path to the service, it's not a great idea. Also, passing arguments to the command line is also not a great idea. So maybe we will be passing only specific values to the service. And the service will parse those values and pass them to the OpenVPN. And that's the example number 4. So I was start thinking, okay, how this parser may looks like. And this is C# code of one of those parser. And after a while, I realized that there is some bug here. And if you still doesn't understand, I need to explain how OpenVPN can accept different commands. So there are 2 ways passing something to OpenVPN. First one, using command line, as I give you example previously. And the second one, configuration file. So we are storing every config inside the configuration file. And we are passing only path to the configuration file to the OpenVPN. And in those previous code, they use C# format. So right now, I can pass IP address of the server then add new line, and after new line, specify new command. In my case, it's app command with the path to the bat file. And because format API is not protecting against, injecting new line, it will be working. So when you are running something as a system, you need to know the application, because maybe there are some mechanisms which might be exploitable. Another idea. I look into different OpenVPN software, different VPN software, and one of them has some debugging functionality inside the production code. And having something about debugging inside production, it's not a great idea. So I was start thinking, okay, maybe I can exploit this. And on Windows, we have something called image file execution options. And this is the registry key. And of course, this registry can be modified only if you have administrator privileges. So that's the reason why of the VPN software vendor have this wrapper for this inside the service. And how this works? So we're specifying here exe name. And when the operating system is executing some binary file, it's checking if those exe name exist inside those image file execution options. And if it exists some record for this, instead of executing normally this binary, it run it inside the debugger. And we are specifying those debugger in the debugger key. Okay, so how we can use this? On Windows, there is something called sticky keys. And that's the feature when you press left shift key 5 times. And this window appears. And under the hood, operating system is executing sethc.exe. And in old Windowses, it was possible to replace those binary with the command line. So then, when you pressed shift key 5 times, the command line appears. Right now, it's not possible anymore. But we can still set the debugger for this executable. There is one little quirk here. When you press shift key 5 times, the executable is running in your security user context. So for us, it's bad, because we are a standard user and we want administrator access. But the situation changed dramatically when you log out, because on login screen, there is no currently logged user. So the operating system is executing those binary as a system. And that's the way how we can manage to exploit this. So using third-party service, I am setting command line as a debugger for the sethc. After that, I log out and press shift key 5 times. And the command line with the system privileges appears. So how we can improve our VPN software again? So as you can see, most of my exploits I've written in Python. So maybe service can check who is really sending commands to the service. And if the command is sent through the real client, it's okay. And if it's sent through the Python script, simply don't execute. But again, there is simple idea how we can manage to bypass this. And it's called injection. And this term is very popular in the malware. So injection means run some code in the context of another process. Let's think about some malicious software. This software wants to communicate with the internet. And nowadays we have some firewalls. So when the new process is trying to communicate with the internet for the first time, we see the dialog box. And of course, malicious software don't want to show this dialog box. So they are injecting their own code inside the, for example, Internet Explorer. And because Internet Explorer is a browser, which is used to browse internet, there is no firewall. And the same idea will be used here. Instead of passing commands directly to the service using Python script, I am injecting my own code inside original client. And from that client, from the context of that client, I am sending my malicious payloads to the service. Another idea. Previously, I showed you that one of the vendor check MD5 of the file. This vendor check digital signature of the file. So the idea is the same. I cannot create fake digital signature. Also, this vendor protect against passing anything to the command line. So I cannot use the same trick I showed you earlier. So how we can exploit this? Service is checking digital signature of the OpenVPN binary. But this binary is also running some dependency. And on Windows, they called libraries and have .dll extension. And the service is not checking digital signature of the libraries. And because by default, Windows is running libraries from specific paths. So first, they're trying to find library from the current directory. It's possible to exploit this using fake DLL. So the exploitation looks like this. We have OpenVPN binary, which we are copying into our new directory, for which we have write permission. And then, instead of copying also the original DLL file, we are creating our own. And our own DLL file can look like this. As you can see, we are setting some exports, so the DLL will be loaded successfully. And after that, inside the DLL main functionality, so it's the place which is executed as the first when the library is loaded, we are creating new user. So very simple way to bypassing digital signatures. And that's the last example with the VPN software. And as you can see here, having very simple functionality, so running OpenVPN as a system, it's not so easy to do. Right now, I will show you how it's possible to obtaining system privileges using Autoupdate. And here, I am talking about some Dell software. First, I will show you very simple Autoupdate design and how to exploit this. And then we will be adding some new features and showing how to exploit them too. So how the Autoupdate functionality may look like. So we have this service which is running as a system. And this service is sending some requests to the external web server. And the web server is checking if we have the newest version of the software. And if we don't have newest version, it returns new binary. And the service is downloading this binary and executes it as a system. So the exploitation is simple. We need to do some local man in the middle. And we can do this using, for example, host file. So we are specifying that original server has local IP address. So the exploitation looks like this. Service is sending requests to the external server, but because we modify IP address, it's sent directly to localhost. And then we give them the fake binary. But we cannot do this because on Windows, in order to modify host file, we need to be administrator. But hopefully for us, there are another way to doing the same thing. And one of them is proxy, especially in corporate software, because in big companies, internet is mostly filtered using proxy. So most of the software vendors which are creating software for big companies also using proxy settings. And hopefully for us, any standard user can modify proxy settings. We only need to go to the Internet Explorer settings and then put our proxy connections. And the exploitation looks like this. Service is sending some requests to the proxy, which we control. So again, we can forge the binary. But the situation is changing dramatically when we put HTTPS here. Because I cannot create SSL certificate which is valid for the domain which I do not control. And of course, I do not control Dell domain. So how we can exploit this? First, I need to show you how the certificates on Windows looks like. So Windows have two root stores. And the root store is the place where the root certificates are stored. And what's the root certificate? It's the certificate which is trusted by the system. So when your certificate is issued by one of the root certificate, it's globally trusted. So we have two root store. First one, computer root store. And if you have some certificate there, it's globally trusted inside this computer. So even system user account is trusting those root store. But unfortunately, only administrator can add new certificate there. On the other side, we have user root store. And every user can add own certificate there. But those certificates are only valid for us. So you may be thinking right now, okay, but in our case, we need to have some new root inside computer root store. But we don't have administrator privileges. And you're right. But that's the place when the Dell is made a mistake. When the Dell sends some request to the external web server, they are using impersonation. And impersonation means execute code under another user context. So how this looks like? When the service is sending request to the proxy, it's changing for a while its user. So it's not system anymore, but is our currently logged user. And because we can add some new certificates to our root store, we can also create certificate for external domain. And because service is right now our user account, it's trusted. So that's the way we can forge binary. In this example, Dell also check digital signature of the file before execution. But as you can see here, again, they are running this check in impersonation state. So final exploitation looks like this. We need to create two certificates. One certificate which is valid for external website, and one certificate which is used to sign binary, our fake binary. And of course, all those certificates are issued by the root store. So as you can see here, creating auto-update mechanism, it's not an easy task. And the last type of software I want to show you today, and it's UPS software. So I will start thinking why the UPS vendors are adding some external software which we need to install on our computers. And when I check a few of the software, I noticed that most of them have one functionality in common. So there is something called on shutdown. How this works? So where there is some power issue, the UPS is notifying computer, hey, there is some power issue. And then the service is executing some previously specified file. So I will start thinking, okay, so here we can specify some file. Maybe they are running this as a system user. And as you may expect it, yes, they are running this as a system user. So my second question was, okay, so what I need to do in order to modify those files? Do I need to be administrator? Maybe there are some credentials, or maybe everyone can change it. So example number one, there is some beautiful client interface. So when we open this client interface, they ask us for a password and for the login. And I don't know any. And also I don't read any documentation. So I do some reverse engineering. And as I saw, they indeed check passwords inside the client interface. But they sending commands directly to the service without any authorization. So they were using simple Java remote method invocation protocol. And as you can see here, it's simple sending some data to the service. And there is no authorization here. So I don't need to log into the graphical interface. I can modify those settings using my Python. Okay, so we have first part of the exploitation. We managed to modify path to the binary, which will be executed as a system. But I also want to exploit this remotely. So having, for example, some Metasploit connection. And when I have local access to the computer, it will be easy. I will simply put off the cable and there will be no power. So the UPS will send message to the service. But let's assume that I don't have local access to the computer. So I will start thinking how the UPS communicate with the service. And it looks like that they are using very old SNMP protocol. So in order to tell the service that there is some connection issue, you only need to send packet which look like this. And of course, for different vendor, the packet look different, but the idea is the same. So that's the way how we manage to exploit UPS software. First, we are setting external file which will be executed as a system, and then we are sending SNMP connection and told them that there is some power issue. Example number 2 is very similar. Right now there is no client interface, but we have some web interface. And again, there is some login and password inside those web interface. But still, after we log in, the commands are sent directly to the service without any authorization. This time they were using different protocol. So again, I don't need to know passwords in order to modify on shutdown file path. And then example number 3. This time, software vendor indeed checking credentials. So I will start thinking, okay, so where do they store those credentials? Maybe I have read access there. And indeed, they were storing this inside the program files. And on Windows, every user, every standard user, by default has read access to the program files. And as you can see here, built-in user has read access to the config file. And the configuration looks like this. Great, we have admin and password. So I send a message to the vendor, hi guys, you need to change this. And after a while, I got new build. And of course, they doesn't change permissions, so still every user can read the config file. But right now we have something called advanced encryption. And as you can see here, password looks differently. But let's think for a while about this password and replace dot with the equal sign. And then this password looks very familiar to the base 64. So I was trying to decode this password using base 64, but it failed. Okay, so we need to somehow reverse engineer this binary. And after a while, I realize that indeed they are using base 64, but they changed the dictionary. So they were not using the standard base 64 dictionary and create own one. So right now you see that advanced encryption means base 64. And that's all I have for you today. I hope you enjoyed this presentation and learned some new stuff. If you like my research, you can follow me on my Twitter. And if you have any questions right now, I'll try to answer them. Okay, so nobody. So thank you very much.